Advent of Code 2023 day 11. This island's filling in nicely, isn't it? And we're gonna explore the new island now, right? Day 11, cosmic expansion. You continue following signs for hot springs and eventually come across an observatory. The elf within turns out to be a researcher studying cosmic expansion using a giant telescope here. He doesn't know anything about the missing machine parts. He's only visiting for this research project. However, he confirms that the hot springs are the next closest area likely to have people. He'll even take you straight there once he's done with today's observation analysis. Okay, maybe you can help him with the analysis to speed things up. Maybe. The researcher has collected a bunch of data and compiled the data into a single giant image or puzzle input. The image includes empty space and galaxies. Scoop says, easy day. Oh, good. Good. For example, this. The researcher is trying to figure out the sum of the lengths of the shortest path between every pair of galaxies. Are we going for straight distance or Manhattan distance? However, there's a catch. The universe expanded in the time it took the light from those galaxies to reach the observatory. Due to something involving gravitational effects, only some space expands. In fact, the result is that any rows or columns that contain no galaxies should actually be twice as big. Oh. In the above example, 3 columns and 2 rows contain no galaxies. These rows and columns need to be twice as big. The result of cosmic expansion, therefore, looks like this. Equipped with this expanded universe, the shortest path between every pair of galaxies can be found. It can help to assign every galaxy a unique number. Maybe it can help describe it, but I don't think I'm going to do that. In these 9 galaxies, there are 36 pairs. Only count each pair once. Order within the pair doesn't matter. For each pair, find the shortest path between the 2 galaxies. Oh, okay, so it is Manhattan distance. Up, down, left, and right. Exactly 1 dot or hash at a time. Okay. Shortest path between 2 galaxies allowed to pass through another galaxy. For example, here's one of the shortest paths between 5 and... Okay, I think I understand. And for our sample input, it's 374. And then we're looking for the sum of the lengths. Okay. Let's get the input. Day 11. So it's 140 lines. And it's probably 140 calls. 20, 23, 11, text. There we go. Yeah, it's 140 columns, 140 rows. Okay. And how many, just as a quick sanity check, I'm going to look -v on that. Okay, so there are, in this input, there's a total of 6 rows that don't have stars. Galaxies, sorry. Columns aren't going to be as easy to compute. But at least I can sanity check my rows. All right, let's dig in. Change the zeros to ones. Stick this on here. Jump up here, create the file, fill the file in. There we go. All right, git add source, git commit -m 23 day 11 temp. All right. So I think we want to store the locations in a hash set. I mean, that's my usual galaxies hash set, right? One of these days, I'm going to create a grid class that I can just say AOC lib load grid and file name and get everything just loaded, because this is super common to have dots and hashes, right? But meanwhile, we'll do it by hand. Let lines equals AOC lib read lines input 2023 11.text for row line in lines iter enumerate, call ch in line chars enumerate. If ch is equal to hash, then self galaxies insert row call. And then down here, what we can do is just print out, have this print out how many stars there are. Self galaxies len. How's that? That's bad. I64. How's that? Better. So we have 452 galaxies. That's a good start. How are we going to do this row and column expansion? I guess what we could do, one thing we could do, let's do it this way. Let row offset equals 0, right? And we could just insert the offset here. And then up here we could say let scene galaxy spotted. We'll start off with false. We can set it to true. And then at the end of the row, if we can say if not galaxy spotted, then increase the row offset. Right? That gives us the rows at least. But that doesn't help with the columns. And then I have to go back and post-process all the columns. We can figure out the columns, right? Using the same kind of technique. We can say let calls equals, call counts. Right. What I can do is count up all the galaxies in a column. I don't actually have to count them. I can just say call has galaxy, and this is just a false semicolon lines 0.len. Right, and then this is just a bunch of rules saying this column doesn't have a galaxy, and then if it does, we can say call has galaxy. Call is true. And that'll give us whether or not we saw a galaxy. We could print that out too. Oop, down here. Oh, vec, bang. I'm seeing shrews everywhere. You see any false? Oh, here's a couple of falses. Okay. So how many falses are there? I see one here. All right. Let's do that. Let's say call has galaxy iter filter x count. Not x, count. 8. It says 8 over there for 8 columns that don't have galaxies. How does this help? That's, yeah. So how are we going to do this? Okay, so here's what I'm kind of thinking of doing. Is for each one of the offsets, what we could do is create an array that says for a given row, instead of doing it this way, for a given row, let's save what the offset is. We'll just insert these as is. And then up here, what we'll do, as we're parsing, we can say call row offsets the vec I64, and the call offsets is a vec of I64. Right, and as we're parsing through the row, we can just push the row offset here, self row offsets, push row offset. Right, let me print that out. Let's see what that looks like. Like this, row offsets. Oh, I forgot the word self. Yeah. So I'm guessing that the first row is all the way down here that has the that's missing a galaxy. So that way, as we loop through, what we can do is we can just, because we're just trying to get the distance. I don't know what part 2 is going to be. Part 2 might mess everything up. But if we're just trying to get the distance, we can just add 1 for any galaxy that's on the, well, there aren't any galaxies on this row because that's the one that had no galaxy spotted on that row. So we'd add 1 for any here, and then 2 for any that are in this range here, right? All the way up to here. This is interesting. This went 3, then 4 right away. So there must be 2 rows in a row that don't have any galaxies. I think, and then we can do the same thing for the columns, right? Once we're done, let's get rid of this. And what we can say is for call has galaxy. Can I do it that way, or do I have to iterate? No, it says okay. So if it's true, then we're good. So let mut call offset equals 0, right? And then if column is true, oh no, we're looking for the falses. If column is false, then we're going to increment the call offset. And then we want to set, oh, we'll say self call offsets, push call offset. So we can print that out as well. And let's use the test input for this. Let's just grab this guy over here. Right? And then we can take a look. Now what this is saying, this is the, what did I print first? The row offsets first. So this is missing galaxies in this row here. So 1, 2, 3. So this gets offset by 1. This gets offset by 1. This gets offset by 1. And then this has, this line has no galaxies. So this gets offset by 2. Okay, I think this is going to work. And then for the columns, I guess, did they tell us which columns are missing? Yeah. So it goes, looks like 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I think it's doing the correct thing. So let's see if we can come up with 36 pairs. Let's see if we can come up with 374. How do we do that? So we're going to loop over all of the galaxies for galaxy in self galaxy. Oh, I can just do it this way. Self galaxies iter. The galaxy is just a row column. Oh no, I have to do between every pair. Okay. In that case, what I'll do is this: let galaxies equals collect back. Right, and that way I can do a double loop on it. It's a reference to the tuple, but that's okay. That shouldn't matter. I can say for I in 0 dot galaxies len -1, for j in I plus 1 dot galaxies dot len, And then we have I and j, galaxy I and galaxy j, and we'll compute the distance between them. Let gi is equal to galaxies of I. Oh, let's do gi row. How about I row and I call? Right? It's going to be this plus self row offset and then galaxies I.1 plus self call offset. Right? And then we do the same thing for j. Offsets. J, and then we just get the distance, right? So let mut total distance equals 0. Total distance plus equals I row minus j row abs plus I col minus j col abs. There we go. And then we should just be able to print out the total distance. Scoop says for I, gi, and self-galaxies, iterate enumerate. For g, gj, and self-galaxy enumerate, skip I. Oh, okay. Yeah, let me see if I can get this to work, and then I'll try that out. I mean, this is a standard pattern, though, right? Starting from 0, going to -1, and then starting at I plus 1, going to the end, right? Total distance. All right, let's see what we get. 276. That seems low. Oh, this is. Oh, it is low. Yeah, I was saying this is the real input, but it's not the real input. This is the wrong input. I mean, test input. Okay, so we have a problem. Yeah, Scoops. Yours way is more rusty, right? And my way is more C-like. But I'm happy to change it once I figure out what the bug is. What's the bug? Why are we? Let's do this. Dump out the galaxy, and it's going to go to this. Oops, like that. Scoop says row offset is paired with the call offset is paired with 0. No, I do row column. So 0 is row and 1 is column. Galaxies of I, and then I row, I call. All right. So the one at row 1, 7. That must be this guy here, right? Yeah, I'm doing it for every. I should just do it. Yeah, we can simplify this code, right? We don't have to calculate I row once. There. So now it says 90, which is this guy, is going to not. Okay, see, that's wrong. Right? And 17 is going to 17. That's right. 4. 1, 2, 3, 4, 6 is going to 47. That's right. So it's only partially correct. 5, 1 is going to 6, 2. That's wrong. What? Oh, I see what I'm doing wrong. I'm using index I. Scoops, you just saw that too. Okay, very good. That's dumb. I shouldn't be doing I here. I should be doing galaxies. This is going to be awkward. I have 0 and galaxies I have 1. And the same thing down here, right? And that blew up. Oh, and I have to as use size it. Okay. 374. Okay, thank goodness. Let's get rid of that. So, okay, let's use the real input. We get a very big number. Very big number. And it is the right answer. Yay! Okay. Yeah, look at that. Somebody's suggesting something similar. So we can do that here. If we do this, we actually don't need I and J, right? We don't need to do the enumeration. We can just say for I. Let me commit these changes first before I break it. Git status, git add source, git commit -m 2023 day 11 part 1. So I can say for first in galaxies iter, except I don't want the last one. How do I eliminate the last one? For second in galaxy, oh, I do need the index I. You're right, Scoops. I need the index I to skip. I first in iter enumerate galaxies iter skip I. And then this becomes first. Oh, why did I do that? There we go. I went to hit B and I hit N because I have a split keyboard. So this becomes first. Yeah, maybe this would have been easier to spot the error. If I had done it this way to begin with. Let's see, does that build? Does it run? Does it give me the same answer? It does. Okay. Yeah, that's more rusty. That's more rusty. The only thing that would make it more rusty is to make this a giant chain, right? I could map that into this thing and then map that into an iterator that does that and then yields all the distances, and then I sum them at the end. But I think this is easier to read. All right, git status, git commit -am cleanup, rusty cleanup. All right. Scoop says I couldn't figure out how to chain it cleanly. Yeah, I mean, let me just think. Let me just type what I was saying. Source AOC 2023-11 there. Nope, that. So would it be something like galaxies iter enumerate map? Come on, map IDX first, right? And then you'd have to generate this thing here. Oh, you need to do this first. And then say, I don't know if you can do this. Except, yeah, we're just borrowing it read only twice, right? Skip IDX map second. Sum I64. right? Would this work? And then this would just be this. Let's see if that works. We can't, I messed this up. Where does that match with? That matches with that. That seems right. Oh, am I missing a one on here? No. This is hard to read, isn't it? This is here. Then we map over, we loop over these guys. We yield this out of here. Oh, I'm missing the closing brace. I see. Thanks, Scoops. I think I just need to do that, right? Yeah, okay. The method call chain might not have the expected. I64 can't be. Oh, I probably have to sum these up here as well. Yeah, there you go. Now, which one's more legible? The one on the top or the one on the bottom? I definitely prefer the one on the bottom. All right, boom, done. Okay, we're clean. We're clean. All right, let's take a look at part 2. Galaxies are much older and thus much farther apart than the researcher initially estimated. Now, instead of the expansion you did before, make each empty row or column 1 million times larger. Oh, okay. I was kind of half thinking in the back of my mind, he was going to say, you know what? It's not that the blank rows are multiples of whatever, but your observation starts here and radiates outward. So the farther it is, the more distance you have to expand away from 0, 0. And I was thinking, that's going to be really complicated if we have to do that. Right? But this is just multiplying everything by 1,000,000. I think, unless there's some sort of trick. Let's extract this. Yeah, as a function on here with an offset or a scaling factor. Pub fun actually doesn't have to be pub fun. Calculate distances. Self scale and returns an I64. And it's just going to be this code here. Right? We can pull everything, right? And then just return total distance. And then we just, in here, we call it self calculate distance with a scale factor of 1. Right? And this should give us the same answer. Times scale. Scoop says, is it a scale? You're adding 1,000,000 empty rows or calls only in the empty rows calls. Well, I'm scaling the additions. So let's see if this still works. Nope. Did I typo it? I must have typed out distances. Yeah, it's distances. Okay, so that still works. Part 1 still works. So is part 2 just 1,000,000? Let's try it and see. Okay, I guess it's not a million. Back to the test input. Did he give us an answer for the test input? Oh, I clicked return. I shouldn't have done that. Okay, there. If each empty row or column were 10 times, then the sum would be 1030. Okay, so let's do that with 10 times and the test input. Where's the test input? Here it is. Okay, so I'm higher than the 1030. And we also have one for 100, which should be 8410. I'm off by, it's not like off by a little bit, that's off by a lot. Huh. Let's try 100. Let's see how much that is. 8492. Oh, it's close, though. That's the thing. So it's not like I would be off by... this is 82 higher. What was the other one? It's also 82 higher. Scoop says try 9, and Fastbuy says it should be 9. I would not be surprised if it were off by 1 error. Yeah, I don't want to. Okay, we can do this here. Let scale equals scale minus 1. Oh, that breaks part 1 because part 1 apparently needs to be 2. Okay, 1030. There we go. Very good. And 8410. Perfect. Okay, thank you, everyone. Appreciate the help. So now if we do a million, oops, that's not how you do a million, and switch back to the real input, that should do it. Nice quick day, right? Fingers crossed this works. Is that number smaller? Yeah, it is smaller. Okay. Hey, that's the right answer. Thank you. Thank you, chat. Sidebam says both are 82 higher. Yeah, that was my first clue that there was a scale, it was a multiplication issue. Consistent. All right, that wraps things up for today, which is good because streaming on Mondays is not a good idea for me.